Okay, exercise 9.4.13, and let me get my mouse here. So this one is saying use proposition 9.4.11 to reprove the following. I'm going to focus on part A. Q star is a subgroup of R star. Now the star means multiplication, and R star we've already shown as a group. We just want to show that Q star is a subgroup. Now what is proposition 9.4.11? Proposition 9.4.11 says that let H be a subset of a group G, and H is a subgroup of G if and only if A is not empty, and whenever G and H are in big H, then GH inverse is in big H. Okay, so a subset of a group is itself a group if and only if it's not empty, and it's closed under this operation here, element times element inverse. The proof of this statement is here. All right, so we want to apply this proposition to prove that Q star is a subgroup of R star. Now, a couple of people went to solve this exercise. A couple of people reproved this proposition. Now, if you want to use the proposition, you don't reprove it, you use the result. Okay? Now, that's one thing. Another thing is that in order to apply this proposition, you're going to have to use properties of Q star. If you didn't use any properties of Q star, there's something wrong, because this is not true for any subset. It's only true for certain subsets that have certain properties. So, again, this proof is going to involve using properties of Q star. All right, so there are two parts to the proof. The first is we have to show that H is not empty. The H in this case is our Q star, because this is the subset of R star that we want to show is a subgroup. All right, so the first thing we need to show is that Q star is not empty, which is not a big deal. For instance, 1 is in Q star. So we can say, so let's start with a proof. Okay, first of all, 1 is in Q star. So Q star is not empty. Okay, so that's the first thing. Second thing, we need to prove closure under this operation. So I need to take two elements of Q star and show that one element times the other element inverse is also in Q star. So we can do that by so let's say, I'll call them Q1 and Q2. So let's say let Q1, Q2 be in Q star. All right, now again, I'm going to have to use properties of Q star. What do we know about Q star? They're rational numbers, and they're non-zero. This means that Q1, I can write Q1 as A over B, and Q2 as C over D, where A, B, C, D are non-zero integers. Okay. All right, now I need to show that what I need to show is that Q1, Q2 inverse is also in Q star. That's what I need to show. And once I show this, my proof is finished. Okay, this is true because, well, let's do the division. Q1 times Q2 star inverse. I'm sorry, Q2 inverse, that's going to be equal to, well, my Q1 is A over B. My Q2 is C over D inverse, so that's equal to A over B times D over C. All right, and that's okay to do this because I say that these are non-zero integers. I can take this and without a problem. So that's equal to AD over BC. All right. Okay. Now, since AD is an integer and BC is an integer, thus AB AD over BC. Sorry. Over BC is an integer. This AD over BC is in Q star because it's a ratio of non-zero integers. I should say that it's also non-zero, and this is also non-zero. And AD over BC is also in Q star, and that finishes the proof. Okay, so that's all you had to do for that one.